So if two galaxies collide, then they can either immediately form one big galaxy, or they can go through each other because the stars are so far apart. Everybody feels on the outside of the balloon that they are in the middle of the universe, but the real middle is not on the balloon, it is in the balloon. The real center of the Big Bang is not in any place in the universe itself. But space and time are stretchable, they have energy. If you bend space-time, you need an enormous amount of energy. I am real as a phenomenon. I am real as an appearance.
As an appearance. Wow.
Black holes are amongst the most fascinating phenomena that we have. They hold a lot of information about the origin of the universe.
The beginning of the universe, the Big Bang, was related to the concept of a black hole. The roles of space and time are reversed. Space behaves like time, and time behaves like space. If you come too close to a black hole, no matter what you do, no matter how strong the engines of your spaceship, you cannot go back anymore. If you are close to a black hole, if the speed limit is more than the speed of light, you are trapped.
Let's talk a little bit about Elon Musk and SpaceX.
If Elon Musk would get the money to do so, I could see humans going to Mars maybe in 10 years.
Will the world end?
Stars will burn up. So at some point, the universe will grow dark.
Before we start this podcast, I just want to make one humble request. If you haven't already, please do subscribe to this channel and press the notifications bell icon. This really helps us bring more guests to the show and have the platform to spread wisdom. Thank you and enjoy the podcast.
Piet, it's great to have you on the show today. I'm truly looking forward to just diving into the deepest secrets of the universe today. I wanted to start off by talking about dark matter. The role of dark matter in the universe is one of the great mysteries of modern science. Could you elaborate on the definition of dark matter and why it's important for our understanding of the cosmos?
Well, the reason that it is important is that there is much more dark matter, much more, by a factor of 10 or more, than there is visible matter. So astronomers are studying the universe, but 90% of the matter, we don't know what it is. And then there is also dark energy. There is even more of that. But let's stay with matter for a moment.
Wow. And alongside dark matter, we also have dark energy,
Yes.
like you were saying. How does dark energy differ from dark matter? And what role does it play in the expansion of the universe?
So I realized I should answer the second part of your question first, from the way you started. The dark matter means matter that we can detect, even though it is dark. It is dark, so you cannot see it, but we can detect it by the gravitational effects. So if two galaxies collide, then we can see that the visible matter has an interaction, but there is also a source of gravity much bigger than what you would expect from the visible matter. So if two galaxies collide, then they can either immediately form one big galaxy, or they can go through each other because the stars are so far apart. Two galaxies colliding, it's like two swarms of mosquitoes or smaller insects in a summer evening, and they can just go through each other. So if you did not have dark matter, then two galaxies with swarms of stars, they would go through each other, but then they would also have some friction. They are basically sort of a fluid, fluid of stars, if you describe it in a physics way. They would slow down and they fall back, and after a few times they would form one big swarm, one big galaxy.
Oh, wow. Okay.
But then it turns out that if we actually study collisions between galaxies in detail, which became possible maybe between 10 and 20 years ago, then actually the gravitational mass, which you can measure by the orbits of the visible particles, the gravitational mass was much larger than the mass in the stars themselves, and the gravitational mass did not get stuck. It did not interact. So you could not see it, and it did not interact except gravitationally. So it was sort of a piece of detective work to even detect the invisible matter. If it would have no interaction with anything, it would be a philosophical question. You wouldn't be able to measure it, and therefore empirically it would not exist.
And I just following up on what you asked, this is something I wanted to just bring upon this conversation was, at least theoretically, if we're able to harness that energy or matter, what applications could that be used for?
Well, we don't know. That is the first question. Whenever you start a new research project, you don't know. And it is always in science a complete surprise, or most of the time a complete surprise, what you can do with a discovery. When Maxwell wrote down his equations of electricity and magnetism unified into one electromagnetic theory, at that moment he realized that he had figured out what light exists of. Light is a wave phenomenon in the electromagnetic field. It's not an electric field or a magnetic field does not produce light. It's only the combination of the two which can produce light. But when Maxwell was working on his theory, and other people experimentally, like Faraday and others, they had no idea that they were on the way of discovering what light was made of. So once we know what dark matter is, we may either find out that it is something relatively expected, and we have many theories. So there are literally hundreds of theories of what it could be.
Oh, wow.
Or even more interesting, it may be that we figure out that it is something that nobody could have thought about because the physics was not there yet. So it's an enormous adventure, and I feel I count myself very fortunate that I have a first row seat in this adventure of figuring out what the universe is mostly made of. But that is all about the dark matter part. That is only roughly 1/3 or so. The other 2/3 of the matter that we can detect gravitationally through the gravitational field that it exerts is dark energy. And dark energy is the name for the energy or matter. E is mc square, matter and energy, you can exchange that. The dark energy is completely different from dark matter in that it is the energy of the vacuum. If you have empty space and time, empty space and empty space-time, then you cannot really, you can take out all the matter, but you cannot take out the energy. Space itself has a certain amount of energy, and the bigger space becomes, the more energy there is. And because the universe is still expanding, and most likely will keep expanding, there is more and more energy being created just because there is more space being created.
Wow.
I'm just giving you a very, very quick nutshell, but it gives an idea of how amazing it is to either do astronomy or to be interested in astronomy and to read and hear about it.
No, I totally resonate with you. It's like, even philosophically speaking, it kind of makes you realize how small we are and how vast the universe is, right? And so yeah, that I totally resonate with you that on that front. I also wanted to talk about the early events of the universe. What were, according to you, what were the most important events in during the early universe, and how does the theory of cosmic inflation fit into our understanding of those moments?
Well, you're really asking the big questions, so let me try to be short. The When I started studying the early universe, the very early universe, that was around the time that I had done my master's, and I had to choose a topic for my PhD. Back in Holland, I grew up in the Netherlands, and I started as an undergraduate in astronomy, astrophysics.
Mm-hmm.
But then I realized that the most interesting question, for me at least, and I guess for many people, was not only what can we learn about the universe, the way it is distributed in space, but now that we know that the universe was born, what can we say about the Big Bang, about the very first stages, and the history is very interesting because the everything we know about the theory of the Big Bang rests on general relativity, which was invented by or discovered, depending how you look at it, by Albert Einstein 110 years ago in 1915. And at the moment that he discovered the equations, there was no idea yet about the Big Bang because there was no observational evidence.
Oh, okay.
It was only, I think, 1 or 2 decades later that Hubble, not the telescope, but the man to whom for whom the telescope was named, an American astrophysicist, discovered that the further you look, the faster galaxies speed away from us. It seems like we are in the middle of a stage where everybody flies away, recedes from us.
Yeah.
But then it turned out that in Einstein's equations, you can have a solution for an expanding universe. And just like if you blow into a balloon, then every little spot of the balloon becomes further away of all the spots around it. So everybody feels on the outside of the balloon that they are in the middle of the universe. But the real middle is not on the balloon, it is in the balloon.
Oh, yeah.
So the real center of the Big Bang is not in any place in the universe itself. It's one of the most interesting aspects of it. And the very pithy way of saying that, I wish I would have thought about it, but one of my colleagues a long time ago who started popularizing, I don't even know whom, put it this way: the Big Bang was not an explosion in space. It was an explosion of space.
Wow. Okay.
Isn't that a nice?
That's a very unique way.
Yeah. So most of my friends who are not astrophysicists, when they want to know about the Big Bang, that is the first thing I have to explain, because otherwise, and if I forget it, then the story doesn't make sense.
Yeah.
Since they think that there is something like an enormous explosion, and at some point the question is, where did the explosion happen? And then I see, I forgot to say that it was not in the universe. Or you can also say it was everywhere.
It was everywhere.
Because if a balloon blows up, everything gets bigger. Everything is sort of explosively moving away.
Wow, so well put. I'm so happy you brought up the Big Bang Theory. You know, this is a question straight for the audience, because our audience is very much interested in the Big Bang Theory. But not just that, we've gotten a few questions regarding alternative theories. Could you shed a little bit of light on that? Besides the Big Bang Theory, or what are the most popular or most scientifically sensical kind of theories out there?
Well, there are 2 answers I can give, one historical and one for today. The historical answer is that until 1965, there were 2 competing theories. One theory was that the Big Bang really took place a finite time ago, and we now know it is 13.8 billion years ago. It's amazing. I know the age of the Big Bang to more precision than the age of most of my friends and colleagues, because I generally know how old they are, and within a given year. But 13.8, if I would know my friend's age, I would know which month in which year they were born. It's just... When I started as a freshman, we knew it was somewhere like maybe 10, maybe 20 billion years. And right now we have this enormous precision. The speed at which everything has gone, even in one human lifetime, is just amazing. But going back to the question, what are the alternative theories? Yeah. Until 1965, one theory was the Big Bang. The universe is about 10 or 20 billion years old. The other theory was one of continuous creation, that we know so little about what happens on these enormous scales. Is it really clear that when stars and galaxies move away from us, can we really conclude that there was, can we go backwards, that there was one singularity from which everything receded? There is another possibility. It is possible in principle that the universe keeps expanding, but that there is a tiny chance, a very small chance at every point in space that some new matter is being created. And we don't know how that could be. But even in the Big Bang theory, the whole universe was created in one moment. The alternative is that at every moment, somewhere in the universe, at every place, there is a small chance that a new hydrogen atom, for example, would be created out of nothing.
Oh, okay.
Why not? I mean, if the whole universe comes, why not a single hydrogen atom out of nothing? So if that would be the case, then it would look like somebody was blowing into a balloon, and the balloon would get bigger and bigger. But if there would be more fabric being created in the balloon, it would just always keep going out, and it would not be a singularity in the beginning. So that would be the continuous creation model.
Wow.
And the way that this uncertainty, that these two different theories was finally solved, was that in 1965, the echo of the Big Bang was found. That sounds very strange to see it.
Yeah.
Oh, I love to tell this story because
please.
It's so beautiful.
Yeah.
It was the defining evidence, the final evidence, was found in New Jersey.
Oh,
not so far from here.
Okay. Yeah.
There was Bell Labs had built a big radio receiver in order to measure the radiation from the universe, the background radiation. Okay. I think the reason was that for communication in general, television and telephone, etc., if you have radiation on larger or smaller wavelengths, then you want to know what is the background from the universe. It's not very much, just like the starlight. It's not very much compared to daylight, and not radioactive. The radiation for example, in the microwave background. Doesn't carry much energy, even less than starlight. So actually, that is not quite right. I take that back, but let me not make this too complicated. So the total amount of energy in the radiation in the microwave background is very small compared to the mass in stars and everything else in the universe. But it is measurable, and people were interested in getting a better measurement. And this particular story, it's a long time ago I thought, or even I talked or even thought about it. The telescope was made for radio communication.
Okay.
But in microwave background. Now I got it right. And when they started to operate the telescope, then they thought that there was something wrong in either the design or the construction, because they kept finding some background radiation.
Okay.
So it's much more interesting than my first version, what I vaguely remember.
Background radiation, okay.
They did not expect a background.
Wow.
But then they found a sort of a hiss. If you put it into sounds, equivalent of radio, and they could get rid of it. And finally, they took things apart and put it together. And finally, they had to admit, this seems to come from outside the Earth. This is not something wrong with this new type of telescope. And after whatever it was, a few months or so, they came to the conclusion there was a new source of microwave radiation that nobody knew about and nobody expected.
Wow.
And then there is a long story, and books have been written about it. The bottom line was that in Princeton, there were some astronomers who were familiar with the theory of the Big Bang, and they realized that the amount of energy in the microwave background was just about what was expected as an afterglow of the Big Bang. Or maybe you should say, because it was a radio telescope, I like to say the echo of the Big Bang. These are all metaphors. But, so that is how the smoking gun, the echo of the Big Bang was discovered. And then there was no discussion. I mean, point made, discussion closed. The Big Bang theory was correct in the broad outlines. But if we now fast forward to today, then right now we don't know how the Big Bang got started. And we don't know what happened before the Big Bang, if there was a Big Bang. After all, if the Big Bang is an explosion of space, maybe the Big Bang was an explosion of time. Or maybe not. I mean, we know so little about the big questions. The typical astronomer spends his or her whole life fiddling with trying to understand a particular type of star better, or a particular type of galaxy. And together, as a international community, we make incredible progress, where everybody is just sort of, it's like working on a tapestry and putting a few extra threads in there. But meanwhile, the really important questions, we don't even yet know how to handle it.
Wow.
But the good news is that if you keep weaving more and more of the tapestry, at some point, you start to see whole new patterns. And I have great confidence that in the next few decades or more, as long as humanity is wise enough to use the knowledge that it has and doesn't blow itself up in one way or another, as long as human civilization continues, I think I wouldn't be at all surprised if also these big questions will be solved. In my life, I've seen so many of the deepest questions, up to the Higgs particle, for example, which I'm not going to talk about, even if you ask me, that would be too much another day. That the structure of the Big Bang during and before the explosion is completely open. Now, the final word on this, since I'm sure you have other questions, I'm sorry to go so long.
No, please feel free to elaborate as much as you want.
Okay.
Please.
The the final and major point, and that is often also mistaken, understandably, for the popular explanations. The most important aspect, maybe, if anything, somebody listens to the podcast and as a take-home message, is that whenever scientists talk about a singularity, they don't really mean it.
Okay.
If a theory predicts that there is a singularity in space or in time or in matter or in energy or in whatever, whenever a theory predicts there is a singularity, it's a sign that the theory breaks down. And singularities are wonderful because we want the theories to break down. Science is fueled by failures.
That's true.
If at the moment, actually, the biggest failure of fundamental science is that we cannot find a failure. Very quick sideline. You may have heard of the Large Hadron Collider in Geneva in Europe, which is the biggest machine humanity has ever made. Again, I won't say more about this.
No, please.
It was the place where the Higgs boson was discovered 10 years ago. And that was one of the reasons, by the way, to put something personal in here, that I did my PhD, that after doing my PhD on combined astrophysics and particle physics, I was one of the first people doing that 10 years before the term astroparticle physics was discovered.
Oh, wow.
So it was fun. We had just a few people and we knew each other. And
it's beautiful.
But in that time, I was curious about the Big Bang. I just talked about my master's, having finished that and then looking for a PhD topic. And I decided to learn particle physics in addition to astrophysics because my main astrophysics interest was the Big Bang. But I knew that everything I had learned in astrophysics about radiation, nuclear physics in stars and dust and everything didn't apply to the Big Bang. So I had a great excuse to actually learn a double PhD and learn about particle physics. And at the end, I had to study, I had to choose which one to make my career of, astrophysics or particle physics.
Yeah.
It was really tough because in some way, particle physics was the most fundamental.
Okay.
I mean, the structure of matter. But astrophysics was pretty fundamental too. I mean, especially on the level of cosmology of the whole cosmos, how the galaxies and everything else, including the dark matter and energy, which was not yet discovered, neither of them, when I started my PhD, but it became known at the end, in the 4 years that I took.
Yeah.
It gives you an idea of the dynamic 70s, both for astrophysics and for particle physics. It was a combined golden age. But at the end, I had to choose because there was a whole field of astroparticle physics. I couldn't get a career having a double life. I had to choose one or the other.
Yeah.
And for my PhD, one of the things I had done is to work on computation of the behavior of the Higgs particle. I was computing Feynman diagrams, as they are called officially. And I did that on the supervision of my particle physics supervisor. I had to have two, of course. His name is Tini Veldman. He passed away only a few years ago. And long after I got my PhD, he would get a Nobel Prize for one of the central discoveries, renormalization of gate theories. I won't tell you what it is. He and his first student shared the Nobel Prize in an important cornerstone aspect of the current theory of particle physics called the standard theory. But by the way, you should stop me at some point because it's so much fun to talk about these things.
No, please.
Okay.
It's beautiful having a conversation.
My sense of trepidation when I started being a student of Tini Feldman, because I was probably his number 4 or 5 students, and we all knew that the first student was likely to get a Nobel Prize. So the pressure that brings...
The pressure must be high. I can't imagine.
Actually, the pressure was so great that it was not pressure, because what is the chance that any particular case... But I'm really, because you are so encouraging, I keep meandering. So by the time I got my PhD, one of my specialties was doing Higgs calculations.
Okay.
But something told me that it might not be discovered tomorrow or next year or even 10 years from now. And then I thought, in astronomy, there are so many new discoveries. Even dark matter was discovered, and not yet dark energy. Dark matter was discovered during the 4 years of my PhD. So then I thought, well, I have to bet, and I don't know which of the two fields, astrophysics and particle physics, would be the most dynamic and exciting, but I chose astrophysics. And 10 years ago, which was, let's see, how many years was it after my PhD? Maybe 35 years after my PhD. Finally, the Higgs particle was discovered. So I knew I made the right bet of going into astrophysics on that part. But going back, and I'm putting all the strands of my little tapestry here together. We know now what the Higgs particle is, and it was the last particle which had been predicted, and it behaved just like it was predicted. And for most human enterprises, if you have figured out something and then you are right, everybody applauds and said, "Whoa, this person really got it right and really had a deep insight." But scientists, if you get it a little bit right, that is nice. Oh, I got that part right. But then they focus on what was not right, and they focus on the aspect that failed, and that they could find a clue and a cue to what the next newer, better theory would be. And of course, the old theories remain valid in the area where they are used. I mean, if you go to the moon, you don't use general relativity, you use Newtonian physics, that's good enough. But for other applications, you use either quantum mechanics or general relativity. So, now coming back to the singularity. You see, singularities can produce anything, like a roundabout story, which I just produced inspired by singularities. Singularities are the most heavy ammunition that we can bring to bear on getting a theory to fail, or to recognizing that the theory fails. So if a theory fails and is not quite accurate enough in this or that, then we have to look at what went wrong, and then we have to really figure it out and come up with better theories which will improve the overall knowledge. But if a theory comes up with a singularity, we don't have to be so careful. If something becomes infinitely something, infinitely hot, infinitely dense, infinitely, you name it, there is no such thing as a physical infinite thing. I mean, whether I will leave it to the philosophers to discuss about whether or not an infinity could in principle exist, but in practice, anything we have done either in the laboratory or in the observations in the field, our field is the whole universe, you don't find singularities. Yeah. It is only if you have a number of data points, and then you fit a curve to the data points, and if then the curve, which is your best theory, which fits the data points of the experiment, if that theory runs into a singularity, then you know at that point you need more and better experiments, because the fitting went only so long, and at some point it's sort of like a car in a car race, sort of flying off the circuit. Yeah. And that's not part of the circuit anymore. Mm-hmm. So the name singularity, and now I'll just wrap it all up. Yeah. The name singularity is a name for a theory crashing. Like a car flying off the race circuit and not being part of a circuit anymore. It's not the fault of the circuit, and the circuit was a perfectly nice circuit. The car went too fast. And the observations and the theories were fine too. They don't have singularities. But the theory which was used to explain the observations up to some point in a good way, if you extrapolate the theory, sometimes you completely run into a wall. Or even worse in a racing circuit where you fly off the circuit. Or maybe they have walls too. Let me not get too far off track. No pun intended. So the best theory is the worst one. It's the one which extrapolates to a singularity. Those are the best, because then you can just put it under a conceptual microscope and see what is happening with this singularity. Yeah. So if people talk about singularities in the popular talk, sometimes they get it right as something which is helpful, but sometimes the metaphor doesn't quite work out. So, sorry for this long...
No, please. I think it's very important that you elaborate, because that's how the audience can actually connect to it. So, especially your personal experiences. Thank you so much for that. And even a couple minutes back, you mentioned time. That actually leads me to my next topic. And not only because it's related to, of course, your career as an astrophysicist, but also it's something that's very philosophical, and we have a lot of audience members that are interested in it. So this is for them. Is space-time an illusion?
I thought, now that I've talked about singularity, that it's such a fundamental concept, and it is so often misunderstood. The idea that having no singularity is a failure, to find a failure for a theory. Yeah. I thought, thinking for myself, now I have created a hard act to follow. What next do I talk about? But you saved me. The question whether reality is an illusion, I think, is even more dramatic and more fundamental than singularity. Yeah. But now I feel I cannot come back to your show anymore, because
no, please. In fact, really we're gonna make sure to have you back, because this is such a hard. To be honest, it's not only a deep conversation, but just hearing your experiences and your story, this makes it even more interesting and more relatable for the audience. So thank you for that.
Thank you. Well, is reality an illusion? Mm-hmm. Many of my friends, both in science and in contemplation, the contemplation, I use the word rather than spirituality, or rather than meditation, for the deep study of the mind by people throughout the history of humanity, especially the written history, where we can reconstruct things. Mm-hmm. I don't like to use the word spirituality, because then my fellow scientists get even more worried about me, and they ask me what kind of spirits, and I say no, that's not what I mean. So I say contemplation. I could say meditation, But meditation is more like a tool, and contemplation is more, in my way of defining things, more like what you discover with the tool, more like a laboratory in which to use your tool of meditation. So, because we are now going to a completely different topic, let me just define my terms. Science started as being really science by having a universal community of self-governing experts defining their terms. Some other time I will fill in each of these words, but that is why defining the terms is so important. So, to talk about whether reality is an illusion, we have reality, we have illusion. We could even think about what is means, because this cup is black. That is clear. I mean, grammatically. But what does is mean with such big words like?
It is a big word.
Or does reality have an illusion, or does it act like an illusion? I mean, is, act, do, be?
Very big words.
But so far, the foundation of any scientific approach, you take a few words, you try to at least get some sense of consensus, then you come up with a very simple theory. And the very simple theory you test is a very simple experiment. Now we are going to follow Galileo, who is sort of like the most visible person among a whole group of people who around 1600 started science. So if I want to extend my science from not only particle physics and astrophysics, both theories of matter, if I want to go to a theory of mind, which is my latest project, which I've been working on for the last year.
Oh, wow.
Maybe let's see how far we get.
No, we'll definitely dive into that too. The mind. Oh, wow.
Teaser. The teaser is, I call it FEST.
Okay.
First of all, research is very festive.
Yeah.
That is the one reason. But the acronym, scientists, especially astronomers, like to have acronyms for any telescope or any theory. The acronym FEST I have used for fully engaged science and technology.
Okay.
Fully engaged means for me not only science and technology of matter, but also science and technology of mind. At any moment, anything we do, we deal with matter and mind. So why not copy what Galileo and natural scientists, who used to be called natural philosophers, have been doing for the last 400 years? It is about time to do something similar on the side of mind, with the same methodology of experiment theory, ratcheting your way up in a community of self-governing experts.
Okay.
Everything else, even math, is a secondary thing. Very important, but math is like a tool. It's the underlying principles in my way of understanding science, which nobody told me while I was an undergraduate or a graduate. You just do it, and you don't talk about what it is. That is... Yeah. We could have one conversation about education of science. How much is lacking on a very fundamental level in the philosophical underpinning. But again, let me continue. The idea of combining theory of matter and theory of mind is something that I wanted to do while I was still at the end of high school.
Oh, wow.
And I can later, if I talk about why and how that happened, then I will never go to your question of whether reality is an illusion. So maybe a placeholder for later. when I was 17, I discovered meditation, and I realized that working. I read a book. It was the time of the Beatles going to India, etc.
Yeah.
It was the time that people talked about it. So I found a book about it, and I tried it out. You need a cushion, you need to sit on it, you need to follow your breath. And I realized very quickly that it reminded me so much of when I had built my own telescope, when I had done chemical experiment, or when I was tuning motorcycles, all empirically with my hands. The laboratory for motorcycles was the area where the father of my one of my friends, a blacksmith, had his tools which we can use with the motorcycle. That was the laboratory for them. For astronomy, I had built a telescope as a laboratory, effectively. And then when I was sitting on my cushion and I followed my breathing, I realized how it influenced not only my body, but also my mind. And then I realized that my mind is a kind of a laboratory for studying itself. Like in cosmology, the material universe is a laboratory for understanding matter. Yeah. It was completely parallel. And I was so excited discovering that. But anybody I talked to, either my fellow students or my teachers, very quickly I realized I should stop talking because, first of all, they had no idea what I was talking about. And if they tried to have an idea what I was talking about, then the idea that they got was such a caricature of my idea that I could see them becoming a little bit worried about me. Like, is this guy on? Is this guy okay? Is it? I didn't seem dangerous, but I seemed really, really strange.
That's how the most geniuses are.
So you see. You were a very good interlocutor, since I told you I wasn't going to talk about it, but now it fitted so well in the story, I couldn't help myself.
Please, yeah. No, it did.
So that is how I started with my life dream of being able to sit on a front row seat, to use that term again, not only for, say, the Higgs particle, which I did as a front row seat, but also on an extension of science of matter to the science of matter and mind. I honestly thought, when was this? 55 years ago, when I was 17.
Oh, wow.
Then the year before, the last year of high school, I honestly thought that pretty soon humanity would start a science of mind. And I thought it would come from the science of matter. I knew that from relativity theory to quantum mechanics was only 10 years. And then it was 50 years to go to discovery of a whole bunch of elementary particles. And people were getting close to getting a unified theory. And I thought, well, if these things happen, sort of every generation, you have something really earth-shaking or heaven-shaking or whatever shaking.
Yeah.
The classical gravitational theory of general relativity, then quantum mechanics, then the theory of how all the particles, and theory of everything, which we, in a way, we don't have. In a way, we already have the first candidate, the standard model, but then we have to continue, fortunately. But as I said, the roadblock is that there are no roadblocks.
Wow.
And we can run circles in the beautiful standard model, but we don't know how to make progress further. So when I saw myself with these three amazing things, and the third one being in full bloom, in full progress, I thought, I want to study physics. because I want to have a front row seat at the next discovery after we have a more or less unified theory of matter. What can be more crazy? I mean, nobody had expected general relativity. Nobody had expected that in general relativity, space and time would be dynamic entities, not just containers, but space and time were as dynamic as the matter and the energy contained in it. Black holes, big bangs, we are now used to it, but can you imagine the shock it must have been that space and time they are stretchable, they have energy. If you bend space-time, you need an enormous amount of energy. The fact that it was not just a coordinate frame or a placeholder, that it's very hard to go back and to realize what it must be for the people who first discovered it and then who later first heard about it.
Yeah.
But then quantum mechanics was so much more crazy. Very simply, every elementary particle doesn't have a measurable existence. You can measure some part of it, but not the whole thing. That is the uncertainty relation in quantum mechanics. And now I will really keep this short. But the fact that the building blocks of the real reality, and you see, I am coming back to your question.
Sure, yeah.
Not to worry.
No.
The reality of everything we see around us in terms of matter or light or energy is built up out of elementary particles.
Okay.
But the elementary particles themselves are in a way only half real, because you can measure some aspects. A typical particle, you can measure the position very accurately, but the more accurately you make it, the more uncertain the velocity or the momentum, technically speaking, is.
Okay.
So you cannot pin it down. There is always, every elementary particle lives in this in-between zone between reality and potentiality, reality and virtuality. So our so-called reality is already built up of a mix of virtuality and reality deep down. That is how I would teach quantum mechanics on day one if I would ever teach. By the way, another little personal note. I got a position at the Institute for Advanced Study early on in my career. I just retired, but they are very nice to their faculty members. I can keep my office, and I can, of course, go to the dining room, the lunch room. So my life is not very different from before. But one of the perks of getting a position there is you have very little administration and no teaching obligation. And much as I love teaching, not having to teach means that anytime on the drop of a hat, if there is a new theory or a new observation, I can hop into a plane. I don't have to change my courses.
You can focus more on like the research.
It's a pure research job. So I was very fortunate, especially early on, to get that opportunity.
Yeah.
So in that sense, I was thinking, some of my colleagues teach courses at Princeton University, which is nearby. We are not part of Princeton University. We are a completely separate entity, politically, financially, everything. So that way we can keep our autonomy, but we are close enough that we regularly visit each other. And some of my colleagues like to teach there, teach at Princeton University, across the road, so to speak, across the forest. Really, we are hidden in the woods, called the Institute Woods. But much as I was thinking from time to time to teach, I also saw that by not teaching, I got so much more opportunity to meet diversity of people in a diversity of fields. And as a footnote, in the what is it by now? It must have been 40 years. It's about 40 years ago that I got my job.
Oh, wow.
And in those first 20 years, I was doing mostly astrophysics. But gradually, I started to work in a number of different other fields in science. And then around 2002, the institute started a new program of interdisciplinary studies. And I was volunteering for leading that program. And in the next 20-some years, I had a great excuse to not only do astrophysics and physics, but also, every other natural science, including some philosophy and some other areas related to social science and humanities. But let me not go further into that topic. So, reality. Is reality an illusion?
Yeah, it's time. Yeah,
I've sketched the overall reality context in which I was trying to answer that question.
Yeah,
the question gripped me in high school.
Oh, okay.
It kept with me as a very serious hobby, you could say. And given that I had more free time for research than almost everybody else among my colleagues in physics and astrophysics, I had enough time to continue my interest both in the practice and the theory of meditation, contemplation, etc. So I want to have it all.
Yeah.
When I was doing physics, I couldn't choose between astrophysics and particle physics, the two extremes, so I did both.
Oh, wow.
And when I got the freedom to choose my own research, independent of grant requirements or other institutional requirements, I decided to study both matter and mind, even though astroparticle physics had just begun when I became a graduate student, but there was no name for it yet. But the type of science of mind, in analogy with science of matter, had not even started.
Wow.
So that's why I spent most of my career on interdisciplinary research between, say, physics and biology, and I worked with paleontologists about asteroid impact. Oh, by the way, that was a fun thing to do because I got an asteroid named for me.
No way.
So that was a nice little perk on the job on that research project.
Oh, that's good for you. That's really nice. That's amazing. Yeah.
Actually, another anecdote, is it okay? I mean,
of course. Yeah. No. Yeah, please. I'm enjoying it. Yeah. And I'm sure the audience members are going to relate to it as well. So that's really beautiful. Yeah.
Well, soon after an asteroid was named after me. By the way, normally they give either the first or the last name, but my first and last name are so short that my asteroid is called Piet Hut.
Oh, really?
Not just Piet or Hut, since they have only so many letters and they discover so many asteroids. It's like a password. It has to be at least probably 6 characters, I guess. The asteroid Piet Hut, when my colleagues heard about it, then they also realized from the description that it was moving in a garden variety orbit between Mars and Jupiter in a more or less circular, not exactly, they are all elliptical, more or less circular orbit. And several of my colleagues independently started laughing and made a joke like, how can Piet Hut have, who is so eccentric, get a circular orbit for an asteroid? Because they expected me to have one of the more circular ones, ideally one colliding with the Earth, maybe.
Okay.
But anyway, that's the end of the anecdote. So, no, really, the question of, is reality an illusion? Every soundbite can be misunderstood, and every soundbite only makes sense if the soundbite contains elements which are understood and shared in a particular community. So, Bohr, one of the central figures in the discovery of quantum mechanics, Niels Bohr, he had a great quote that he used, an expression that he used in the terribly exciting time of discovering quantum mechanics and figuring out what to do with this. It's so different from any other physics we have seen before. He came up with the expression, the opposite of every great truth is a great truth.
Oh.
And given, and he sort of made, he enjoyed making people perplexed and saying, well, this and that, but enough anecdotes already. I would say, let me follow Niels Bohr and let me talk about why reality is not an illusion. Or that is, I think, the exact opposite of whether reality is an illusion. So many of the people who I talk with about these topics have said at some point, sooner or later, reality is an illusion. And what they mean with that, I agree with.
Okay.
But I don't like to use those terms, and I like to look at an opposite truth of the truth that reality is an illusion. And I would say reality is what it is. Reality is the ultimate bedrock or the ultimate term, the ultimate concept. It's still a concept, so it's not a real thing.
Okay. So it's not a real thing according to you, or?
Well, concepts are concepts. Concepts are not. If I talk about matter, the word matter is a concept. It's not matter itself. And because at age 1 or so we were beginning to learn a language, and we are beginning, and through language concepts, and we are beginning to learn the difference between self and other, which are the biggest concepts, which are absolutely necessary for practice. If you can't make the difference between self and other, you can't function in society. If you can't speak a language, you can't function in society. All very important, but we are so fully trained in a complete 24/7 curriculum of meditative experience in our first year to become absolutely convinced that I am the subject, different from all the objects around me, that it will take more than 1 year to undo that in meditation or contemplation later on. And these basic ideas, not every word in a language is like a concept. And the biggest concepts are self and other and time, the past and the future, etc. So we use these concepts as we are doing right now, and you're playing the role that you have. I'm playing the role that I have.
Exactly.
But if you start looking at what is behind the concepts, maybe the best image that I can think of the top of my head, and I use different images different times because almost everything we deal with these concepts you can make an image of it.
Yeah.
If you go to a showroom with furniture, then at least when I was growing up in a showroom, you had nice couch like this beautiful one here. You had tables like this really quite nice table. It's a beautiful environment you have created here for your guests.
Thank you.
All of those in the showroom would have some plastic around it. If children would come in and they would have dirty hands and start playing with it, the plastic can protect the real furniture.
Yeah.
So that image, I think, works quite well to explain the function and the problems created by concepts. If we talk about a cup, like this cup of coffee, which I forget to drink because it's such an exciting.
Yeah, I know we're flowing so beautifully. Yeah.
And indeed, very nice coffee.
Oh, thanks to my sister.
Going with the furniture.
Yeah. Yeah.
So, the concepts are really helping us and hindering us. A piece of plastic is a nice way of dealing with furniture in a showroom. You can still see what the furniture is. Children can have their dirty hands on it and you can wipe it off.
Yeah.
All very nice, but you are no longer directly in touch with the thing itself. Literally. It's a nice metaphor. You are not in touch anymore.
Not in touch.
So, if you want to sell furniture, you can imagine that using plastic is okay. But if you would sell reality in a showroom and say, this is reality, then if you use concepts, then it becomes invisible.
Yeah, makes sense.
You cannot, I can, well, let me come back finally to your real question. So that is my idea about concepts, and all of contemplation is to make the step from dealing with how things appear without much theory behind it initially, some and growing amount for young children. At first, there are just all these sense impressions, I presume. I mean, I don't remember, and most people I know don't remember it, but I have that idea. You have all kind of things happening, but then after a year, you find concepts like a handle to talk about with other people and with yourself if you want to reason about something. So you get concepts. You get a language, you get then a sense like, oh, this is my body and I have a mind. I cannot point to it, but I have memories, I have impressions and etc. So you learn that all these things are there, but you deal with them through the concepts.
Okay.
And then if you are lucky enough to get lucky or unlucky, depending how you want to classify it. That would be a concept too, the classification. Let me not give a value judgment. Perfect examples of concepts.
Yeah.
If for those people who stumble upon something like contemplation, to use that word, the holy grail of contemplation is to slowly wean off concepts. You can still keep using them, but you are less and less trapped by them, and you are also able to drop them.
Okay.
And the biggest drop, the biggest plunk, I can almost hear it as the sound of if you can really drop the sense of self, even for a very short period, and the sense of time. They are both the biggest concepts. In just about any contemplative tradition I've come across, Buddhism, in a way, is the most of the ones I have played with and looked in. One of the most conceptually elaborate. For whatever reason, another day, another time. But also medieval Christianity, also Islam, Judaism, Taoism, you name it. And of course, Aborigines as well, although not having a written tradition, it's more difficult to compare them, but the main elements are visible there as well. In all these cases, the challenge is to have both an understanding and an ability to work with concepts for daily life, and also to have the ability to drop the sense of self, after which you cannot speak, you cannot say who dropped a sense of self. And who was there before it was dropped? Because that is the thing. Now, and this very, very briefly,
please.
I promise, this is one thing which over time, the more I thought about it, the more I felt it is so close to what happened in the theory of matter. Starting with Newtonian mechanics as a clockwork mechanism, everything was well defined. Then quantum mechanics, where the moment you begin to do experiments in quantum mechanics and try to make a theory of quantum mechanics, things don't work anymore. The concepts of classical mechanics are not applicable, and the language is not applicable, and the whole way of dealing with quantum mechanics is still much of a puzzle. 100 years after it was discovered, actually in this year, it was 100 years ago, 1925, we still have a number of different interpretations, and they are probably all wrong. And certainly they cannot all be right. That has never happened in the history of science, that when something new was discovered, typically within at most a few years, people had a basic understanding of what it meant, but not with quantum mechanics. So the idea that that the deepest insight is something you can't really get a handle on, that is getting close for the first time in history. That is getting close within the theory of matter to what was traditionally a theory of mind in traditional contemplative traditions. And immediately, and this is extremely important, immediately I have to say that I have to add what I am not saying. I am not saying that quantum mechanics can explain contemplation.
Okay.
I am not saying that contemplation can explain quantum mechanics. I am not saying that there are quantum effects at work in contemplation. I am totally not saying that there are quantum effects in the brain which are correlated with contemplative insight. All of these things which it would be so much fun, depending on your definition of fun, of playing with ideas and speculating how quantum mechanics and contemplation are together. But that is exactly not what I want to do. And I have to say this before I can answer your question. I'm still on my way.
Yeah. No, please.
Before I can answer my question, because the reason that already in high school, for whatever reason, I got that intuition. The reason that I wanted to make, or that I hoped, I didn't want to do it myself. I hoped I would find people who had already started making a scientific inroad into the study of the mind, is that I knew that any step forwards in science was empirical. It was based. The theory was an intellectual idea. Then you do an experiment, and the experiment always wins from the theory, as it should. That is the empirical evidence. The experiment tells you which part of the theory does not fit. And that is a great challenge for the next better theory, as we coming back to the very beginning of our conversation.
Yeah.
So that part I wanted to see in a theory of mind, and in a practice of mind, in a science of mind, theory and experiment. And in science, science was all about science of matter, and in study of the mind, it was more like engineering in a pre-scientific stage. And I don't mean that in a negative way.
Okay.
Galileo did not invent engineering. There were already around him cathedrals. There were paper mills. I mean, physical paper mills rather than in publication.
Yeah.
There was so much. I mean, the pyramids was already a few thousand years old. And what he did was, as a thought experiment, dropping stones from a tower. How simple can that be? Rolling stones from an inclined plane and checking with his heart rate what the time dependence is, depending on the connected with the space dependence of these motions. So simple compared to the best engineering developments of his day and much before his day. And yet, that systematic way of very slowly taking the most elementary phenomena and really understanding them and mapping out their behavior using mathematics. And whether we ever use mathematics and in which form in a theory of mind, we don't know yet. Probably we will. Quite likely it will be different types of mathematics. But we will call it mathematics just out of habit.
Yeah.
I mean, topology is so different from geometry and algebra or even calculus. And topology doesn't look like any of the old mathematics areas. But who cares? There is something completely new. Let's call it mathematics, and then mathematics becomes wider, like science in general. So if people ask me, will you use mathematics in theory of mind? I say, first of all, I'm not the one using it. I am trying to hope to collect enough other people to start, or not even start, to let a community form by those people drawn to it. And that community will find a way of discovering it. I feel I'm just sharing an idea whose time has come, and I am still almost convinced, that there must be quite a few people who have thought about this, and for whatever reason, I haven't run into them. And most of them probably like me until I retired. Most of them probably thought, well, that is too big a step, and let us not try to jump to the end of the rainbow. Let us just do our normal work, and let's handle this when it comes. I want to say something about the rainbow too, but at this point, one other placeholder, AI. AI is what forces us to do a science of mind. Not only a science of matter, but AI is working on the level of software, not on the level of matter, but on the level of, you can say, software. I think is a good term.
Yeah.
It's nothing material, and it's the first time in history that we now have machines which don't only amplify our muscles, being stronger, or our eyes being more precise, but actually beginning to emulate our minds. So I think the only way that we are really going to have any hope to talk sensibly on a deep level about AI is to study AI and to study the human mind together in a scientific way, not only in an engineering way.
Wow. I'm just because you're talking about the mind, your story is so amazing because not only are you an astrophysicist and a man of science, but you went deep into the study of the mind and meditation or compilation, as you say. I would love to hear your take on consciousness. Now that you even brought up AI, not only that, part B would be, can AI ever be conscious?
It's an absolutely important question. It is far too early. Any answer I have seen is so hopelessly naive. It would be like asking Galileo or maybe Newton a little bit further, asking Galileo, what do you think about quantum mechanics? He would say, quantum what?
Quantum.
Do you mean mechanics? Oh, I have this beautiful mechanics. I just discovered it. Want to know it? No. What is about the real nature of matter? What's quantum mechanics? Now, Newton could not have guessed. So the one thing I know is that whatever you read in newspapers or scientific publications, we just don't know. But this does bring us back to the reality.
Yes.
Why I think that reality, that I can equally well say reality is not an illusion. So I just mentioned at the end of the rainbow, and I've already forgotten in which case as an expression. Let me take a rainbow. Is a rainbow an illusion? Well, it depends. The way we normally use it is that you say, the rainbow is not real, it's an illusion. If you walk around, it follows you, or you follow it, or both. It is not something material. So if you define an illusion as something which looks material, but isn't, then a rainbow is an illusion. But who says who that you have to use that definition? So if I were to write a children's book, which I've never done, but if I would write a children's book, from time to time I get an idea in the middle of the conversation. This is so elementary. It should be in a children's book, not in a scientific publication or whatever. If I were to write a children's book about a rainbow, then at the beginning, in the page 1, there would be some adult who said to a child, can you see that rainbow? It's not real. And the child is very disappointed. But then the rainbow starts talking. It's a children's book, so a fairy tale. And the rainbow says, who says I'm not real? And then the adult has already walked away. So it's the rainbow and the child. And the child would say, oh, can you talk? And the rainbow says, yes, I can talk. And so can you. Let's have a conversation. And then the child says, but why did this guy, this older guy, say that you're not real? And then the rainbow says, oh, that's a common misunderstanding. They think that you have to have matter to be real. And he has matter and you have matter, you have a body. And you are real, your body is a real body, but you also have a mind, which is also a real mind. And I have light. I am a rainbow, not made out of matter, but I'm made out of light. And I beg your pardon to the older person. I'm quite real, thank you, but I'm real as light. Or, to be even more precise, I am real as a phenomenon. I am real as an appearance.
As an appearance, wow.
the appearance, that is a better term than phenomenon. That is too philosophical. And I don't mean the word, I'm now going back to myself from the children's book. I don't mean the word appearance like in contrast to reality. We say, the cup appeared to be empty, but look, there is still some coffee.
No.
I don't know whether I will come to the end of the coffee, but before the end of the talk, let me...
Please.
Now I can say it appeared that there was some coffee. I thought it looked empty. It had the appearance of being empty, but actually I looked and there was coffee. So my appearance was misleading. That is the normal way. So then we say there was the mere appearance. A rainbow is not real. It's only the appearance of the rainbow. There is not something physical.
No.
And there is also certainly no pot, a golden pot at the end of the rainbow.
No.
But that is not the appearance that I want to use. I want to use the term sheer appearance.
Okay.
So a rainbow is not, parenthesis, physically real, but a rainbow is sheer, is a form of sheer appearance. But it is an appearance.
It is an appearance. Okay.
You cannot deny that there is a rainbow.
Exactly.
You can take pictures of it, and even if you couldn't, you yourself look at a rainbow and you can talk about it. You can have other people who also see the rainbow, not in the same place if you walk around. But who says that reality should be bolted down to a place?
Exactly. No.
That is another thing the rainbow will say too. I am so glad I'm not bolted down. I pity you humans. You're always somewhere.
Yeah.
I can be everywhere at the same time. I'm beginning to see the story.
Yeah.
Sorry, I just...
No. It's a beautiful example. It's a beautiful example.
Thank you.
Yeah.
But now the question is, the rainbow was was not amused by being called fiction, being called, what did we use? Reality as fantasy, reality as an...
sheer appearance?
Sorry?
You were saying sheer appearance.
It's as an, but sorry, we started with...
if reality or time or reality is an illusion.
Yeah, illusion, the word illusion, yeah. So we started with, is reality an illusion? And then special cases, self and time, and many more. Yeah. If you say, is the reality an illusion? I did a segue, is a rainbow an illusion? Yeah. And I would say the rainbow is real on the level of the sheer appearance. It is really an appearance that is really real. It is an illusion if you narrow the definition, because we have a material body. If we want everything real to be material, then it is not real. But that is an enormous discrimination. Yeah. You discriminate rainbows, like in the story, and you discriminate everything. You discriminate love and hate and wisdom and just you name it. I mean, that is all not real. Well, again, I beg your pardon, that this doesn't work. Yeah. So the answer now is that I would say reality on this level, reality is real. It is real as a sheer appearance. Yeah. And in my FEST theory, F-E-S-T, which you can find on by going to my a homepage at the Institute for Advanced Study. Fortunately, Piet and Hut, the combination, there are very few people and they don't write as much as I do. That's good. So there is just one Piet Hut you will hit if you do a Google. Then at the top of my homepage, I have the word FEST, and you can click on it, and then you go to Substack, and that is where my blog lives. Wow. And then you can find a few hundred pages of me, sort of months by months, working out what the story is.
No, I'll make sure to put that link in the description as well of the video when we release
the description, of course.
We will make sure, definitely.
You can put it there.
Yeah, no, and now I want to. I know we're going deep. I feel like we're only going to go deeper, but I wanted to talk about the Fermi paradox.
Okay.
The Fermi paradox poses a question about the likelihood of intelligent life in the universe. Do you think we are alone in the universe, or is intelligent life more common than we think?
Well, I will hedge my bets here.
Okay.
I will hedge my bets, and now I will try to make it shorter because I'm sure you have many other things. Let me now try to put on a hat of whatever it is, a very punctual Piet.
Punctual Piet, oh, that sounds great.
Which is a hat I don't often wear, but okay. Two answers, which I think are almost equally plausible a priori. One answer is that, there are so many planets in the universe, almost every star has a few planets. We have 10 to 11 stars in our galaxy. There are 10 to 11 galaxies in the visible universe, the observable universe. How can there not be life? There is life here. Why not somewhere else? It seems like a very, very good argument. Now, imagine, because we don't yet know how life has formed, we have many theories. And very short segue, 10, 12 years ago, I was asked to be part of a small team applying for a grant in Japan to start a new institute on the origin of life.
Really? On the origin of life?
We had, there was a competition and there were 3 grants, each of $100 million. Which would be given to the 3 best proposals, where every university in Japan could write at most one proposal. So I was asked by some of my friends in the equivalent of MIT in Japan, the Tokyo Institute of Technology. And the equivalent of MIT or Caltech, I don't want to take sides here. Who knows whom of my friends are watching or listening.
Yeah.
Okay. So at the Japanese MIT, to make a long story short, we got one of the 3 grants. So since then, I've had a great time visiting a couple months a year, meeting so many interdisciplinary people. Since I told all my colleagues in all different fields, if you are a natural scientist, you have no excuse not to study the origin of life. Why? The only life we know was formed on Earth. And so if you want to study the Earth, you can do it as an astronomer, astrophysicist, as a geophysicist, as a geochemist, as a biochemist, as a biologist. You can be a computer scientist, and there are lots of simulations. There are all kind of evolutionary simulations you can make. So as a mathematician, even. So I would, if they ask me, why do you study origin of life? I would ask them, why are you not studying it? Exactly. And then they would say, but I am such and such. And then I would say, but a such and such, we don't have this person yet. And it fits in here with that and then.
Perfect.
So this was so much fun. But end of this little story another day. Back to your question of why I'm hedging my bets. It seems so clear. If I would be a lawyer in court, I rest my case with 10 to the 11 stars and 10 to the in 10 to the 11 galaxies each. There must be one place for where life would have formed. No, I take a different head of the other lawyer arguing for the other side, and I say, thank you very much, Piet Hut. I have to get a pen name, lawyer name. Oh. And then I would say, well, just we don't know how life has been formed. It might be a very, very unusual case. It might be that in the whole visible universe, maybe it happened only once. And then the other lawyer, speaking out of turn, says, "Oh, boo, boo! How can it be such a big universe?" And I say, "Excuse me, the judge says out of order, but also has to smile with this spectacle."
Yeah.
Then I say, imagine, because we don't know what the probability is. Imagine that in a few years, further work done both at this $100 million institute and other institutes, and I would make a pitch for more funding. If we get more funding and more people work on this, it might be that we find out how life formed, and then we can do a calculation of the probability of each step. And there may be one or even more than one, which is really unlikely. And just imagine that the total probability of origin of life on a typical planet would be 10 to the minus 22.
Okay.
That only one, on average, 1 out of 22, 10 to the 22, 1 out of a number of billions, 1 with 22 zeros. That out of 1 out of 10 to the 22 planets would actually make life. Well, if there would be anybody to ask the question, why here? You only can ask that question at a planet where life existed.
Yeah.
So the fact that it was here was not a fluke.
Yeah.
Since we are the only little island in the whole sea of planets where the question can be asked. So, who is right? We cannot decide.
Yeah. Oh, beautifully.
Does that sound plausible?
Yeah, no. It's a very interesting way to put it. We had recently we had Avi Loeb. He's also we all talked about him about aliens too. So it's really nice to get different perspectives on it. But yeah,
he and I overlapped for a number of years at the Institute for Advanced Study, so I know him very well.
Oh, really?
I know him since he just after his PhD, he came to the Institute for Advanced Study as his first postdoc position after PhD.
Oh, wow.
So,
I also wanted to talk about exoplanets. How far do you think we are from identifying truly habitable planets? I mean, these days you're seeing Elon Musk doing everything with Mars, although it is very commercial. Right now, it seems to be what they're doing and focusing on is more like commercial flying over to Mars. But what key factors do you think would be involved in actually determining whether a planet could support life?
Oh,
we're going deeper and deeper.
Yo, I know. I mean, see, the question of a singularity is a very deep one, but a very simple one. And it's deep because it is so simple that the only explanation is a very deep explanation. The origin of life and the question under which circumstances life can begin is the exact opposite. It's such a complicated question, and there is so much. I mean, a single living cell is so complex. Yeah. The history must be extremely complex. So to figure out, to try to reverse engineer a cell is one thing, but to reverse engineer how to make a cell without the ability to order laboratory material from Amazon. You didn't have, nobody had test tubes and nobody had starting chemicals. It is so complicated. We are so far away. I wouldn't even know where to start.
Oh.
But progress will happen step by step. And the most difficult one will be to decide when we find a smoking gun, whether it will be a smoking bushfire or really a smoking gun.
Yeah.
Whether it was a natural, a non-biological origin or really something involving life.
Wow. And I was going to bring this up a little bit earlier because you mentioned AI. I would love to talk about that as well, and specifically in relation to astrophysics. Because, AI is just becoming increasingly important in various scientific fields, of course. But I wanted to ask you, how is AI being used in astrophysics to analyze data and develop new models?
In a large variety of ways. And this is such a rapidly evolving field. I have not been able, and I have also not been willing to spend a large amount of time of following step by step what is happening. I'm very happy to look sort of once a year to see how much progress has been made, because I'm busy with my own
of course.
theories right now. But whenever I look either a year later or even a month later, so much has changed. It is just, it's overwhelming. So, but not only in astrophysics, in every part of being human, I would say.
Oh, yeah. No, changes are being done very rapidly, and yeah, it's definitely really good to get your unique perspective on it. To be totally honest, I feel like I could be asking so many more questions, but I do have to hand it over to my co-host, my sister Amira, to continue this podcast. So just want to say thank you so much for your insightful this insightful conversation. I really feel like the audience will be able to relate to this, and I'm looking forward to release it. And I'm really looking forward to getting all the questions and our who knows debates maybe, but yeah, beautifully explained, and thank you so much.
Thank you. It was a real pleasure.
The first question I have is really just diving a little bit deeper into the concept of black holes. Black holes are amongst the most fascinating phenomena that we have today, and I feel like they hold a lot of information about the origin of the universe. So can you talk a little bit more about that?
Wow, your first question is already so broad and deserves a really deep answer. I would say the beginning of the universe, the Big Bang, was related to the concept of a black hole. A black hole is what you get if you have a single star, or maybe even many stars, together collapsing to a point where the gravity is so strong in the ongoing collapse that even light cannot escape the gravitational field anymore. So that's why they are called black. And they are sort of like a hole in space, in the sense that our best theories predict that the collapse cannot be stopped, and that you will develop a singularity, infinitely high density, infinitely high concentration of matter, which means that the theory breaks down. Albert Einstein's general relativity theory of gravity breaks down at the very center of a black hole, and so far nobody knows what will actually happen. We need a better theory. That is for black holes, but those are localized phenomena. You have a single star or maybe a group of stars, but the Big Bang is very different. It's almost the opposite. The Big Bang is a kind of explosion which created the whole universe. So you could maybe say it is not a black hole but a white hole. It was all the matter and all the light came out of the Big Bang. Although technically it's a little bit more complicated, but in the first approximation.
Mm. When you talk about the whole aspect of the Big Bang happening, according to you, as a scientific perspective, does that rule out the possibility of a God creating the universe?
Well, it certainly doesn't rule out. It also doesn't rule in. I mean, these are, first of all, these are topics which, at least until now, have not been connected with each other in any scientific way. So individual scientists may have their own ideas, but whatever their ideas are, they don't speak for science. Science has concentrated so far on a study of matter and has left out the dimension of the mind while studying matter. Although, of course, now that our brain studies are getting more and more detailed, and not only the brain, the whole human embodiment and the cognitive science progress of how to describe and hopefully maybe even explain human behavior and human consciousness. But all of that is in such early stages that even to define what you're talking about, if you use the word God, it may be that in the English language, the word God is the least defined and the broadest used in many different terms. So.
Yeah, it's interesting because scientists usually have a very different take on this, and I've always wondered that was Big Bang the reason this universe was created? In your personal opinion, is that the most compelling theory of the universe's creation that we have till date, or is there something else?
Well, the question of how the human knowledge from the past about matter and mind, how all of that can be still be useful for the present day is a very tricky one, because if we start with our understanding of matter, the knowledge we had about matter until 400 years ago, until Copernicus, Galileo, and Newton, that period, was all what I would call engineering. The cathedrals were built without much calculations. It was mostly trial and error and finding regularities. They probably did some calculations, but not based on mathematical theory the way scientists do. So everything which was done in building cities and pyramids and everything else was engineering. And actually, animals, beavers make dams, and termites, even much earlier in evolution, built their own little pyramids, so to speak. So engineering is something animals and humans have perfected more and more over time. And then suddenly, when science started, the first 200 years of science, the insight was growing about how planets and stars behave, how you can predict the positions of the planets, for example, how you can learn about not only the motion of planets, but the motion of, say, water flow and gases and all aspects of physics, which is being taught in middle school and in high school, was built up starting around 1600 and was well on the way around 1800. But until 1800, the real applications were still engineering. A steam engine was the use of efficient steam engines probably was the last big step forwards in engineering, which was more or less independent of science. It was just found out by trial and error. And actually, to explain why a steam engine works as well as it does, and let alone to predict how efficient a steam engine could be, they knew that if you try this, if you try that, then it becomes more and more efficient. With the same amount, same weight of coal and heat, you can get more motion. But nobody knew what was the maximum efficiency. If you have one little piece of coal, you cannot power a steam train. That is clear. You need a lot of. But what is the limit? It took about 50 years to find out what the limit was, and another 50 years to explain why the theory of the limit was working. What happened was that after James Watt made a very much more efficient steam engine, 50 years later, Carnot published one article. He would never get tenure these days. Mm-hmm. He published one article in which he showed in a diagram what the maximum efficiency could possibly be for a given type of steam engine. And he basically started the field of thermodynamics by doing so. Thermodynamics, the dynamics of heat, it's triggered by a steam engine. So the steam engines, as an engineering feat, were triggering new theories. And 50 years later, after Carnot, Boltzmann finally started with the motion of atoms and molecules. And from the chaotic motions of molecules, he derived what Carnot had proven as what we call phenomenological, as just the way some things behave without a theory underneath. And then, at that time, science was still a century behind the engineering. But soon after that, fast forward a century, around 1900, when people started to design airplanes, the very first airplanes, if you look at the notes by the Wright brothers and some other people in other countries at the same time, they used a lot of mathematics to design the shape of the plane, the airplane wings, and everything else which you needed, how much power, what kind of propellers, etc. So somewhere in 1900, 300 years after Galileo, to produce new types of engineering, you needed science. So in the last 125 years or so, engineering has been driven by science, but it's only remarkably recently. Mm-hmm. So until then, the whole study of matter was sort of trial and error. And I would say in contemplation, similarly, and I use the word contemplation in a very broad way, like people might say spirituality, they may talk about God, right. But there are also traditions where there are many gods, and even the word God transported from our culture in another culture may have very different meanings. And in Buddhism, you can also say that there is emptiness, or
the concept of no form, the concept of no God with form, right?
So all of those, in a way, you could say they are engineering of the mind. Mm-hmm. And I don't mean that in any negative way. I have the greatest admiration for any type of engineering, but it was not. Contemplation so far until today was not unified in one particular framework which was shared by everybody, the way science is. And also contemplation has generally not been governed by the contemplatives themselves. They were generally embedded in a tradition where the people in power were not contemplatives themselves, which is very different from science, where the people in power are the scientists themselves, and they have to get funding from outside, of course.
Right.
And their applications will be determined by other people, in a democracy by the whole country, or otherwise by a more select group in one way or another. But the development of science always has been led by scientists. And the development of contemplation has been led within every tradition by the contemplatives themselves. By definition, because only contemplatives can really further go deeper into contemplation. Other people wouldn't even know what they were talking about. But all these pockets of contemplation in different tradition and different branches of a tradition have never been brought together in a way that it was one clear community working shoulder to shoulder or mind to mind. And my hope is that will happen soon. And what I'm now doing, especially the last year, is trying to come up with a basic sketch in the hope of finding other people who also make their own sketches, so that we together can start some sort of give a direction in which to start some sort of new science of mind in analogy to science of matter.
So someone was to ask you this question, that according to you, who or what created the universe, and you just had to give like a one-line answer, what would that be?
I would not use the word creation.
Okay.
Because the word creation, by definition, means there is a creator.
Interesting.
The deepest questions I would like to formulate in such a way that you don't build in a cultural answer, because the existing answer is almost certainly wrong. That was a long sentence.
That's smart, right? You shouldn't have any preconceived notions of even what could possibly be the answer before asking it. Interesting. So when we're talking about black holes, a question came into my mind about time. So, of course, time in general is a very fascinating concept in astrophysics, but specifically when we're near black holes, how does time perform? Does it feel or act the same way as it feels right now, like the way we're talking and time is passing by, or near a black hole, is it somewhat different according to science?
Well, it couldn't be more different. It couldn't be more different in the sense that near a black hole, space and time behave the same way. But at the moment that you pass the horizon, and the horizon is the point of no return, if you come too close to a black hole, no matter what you do, no matter how strong the engines of your spaceship, you cannot go back anymore. Because at every point, if you have a normal star, at every point near a star or near a planet like the Earth, you have an escape velocity. If you move from the surface of the Earth with a speed of more than 11 kilometers per second, then you can escape. If you make it 10 kilometers per second, you go pretty high, but you fall back. So depending on the distance to a star or a planet, and depending on the mass of the star or the planet, at every point there is a speed. If you go, it is kind of a speed limit. If you go beyond the speed limit, you will never turn back. If you stay within the speed limit, you fall back onto the star or the planet. Does that make sense?
Yeah, that makes sense. I was just a little stuck on you mentioning no escape and no return. So what does that mean? It's the first time I'm hearing this.
Yeah. And I just wanted to check whether the idea of a speed limit.
Yeah, that makes sense. Yes.
So if the speed limit becomes larger than the speed of light, then first of all, light cannot escape. Light has a speed of 300,000 kilometers per second. If the star is so dense, and if you are so close that the speed limit would be 400,000 kilometers per second, for example, then light cannot escape. It would fall back. So even if you have a beam of light, it would try to go out, but it would fall back onto the star itself. So that means two things. It means that the star becomes black because light cannot go out. But what is more, because in special relativity theory, Einstein showed that the speed of light is the highest speed you can reach. You cannot go faster than the speed of light. So if light falls back, then every rocket, no matter how strong the engine is, will also fall back. So if you try to escape, if you are close to a black hole, if you try to escape, if the speed limit is more than the speed of light, you are trapped. You cannot escape. Does that make sense?
That makes sense. Oh, it's quite fascinating, though, to even... I feel like there's so many things about the universe that the general public is not aware about. It's like we're stuck in a bubble where we feel like this is reality, but there's just so much more that...
Oh, absolutely.
Wow.
So much more to come. Yeah.
Oh, amazing.
So we call it horizon. What we mean is normally if you talk about horizon, it means you cannot look beyond horizon. But if you are... there is a certain area around the black hole where the escape velocity, the speed of escape, is exactly the speed of light. If you are outside there, then you can always fall in. But if you're inside there, you cannot go out anymore. So for somebody inside, it is really an horizon. You cannot reach the horizon anymore. So this brings me back to the question of time, which you asked. I went a little bit roundabout.
No, it was great, yeah.
But here, the most remarkable thing is that within the horizon, the roles of space and time are reversed. Space behaves like time, and time behaves like space. And that sounds crazy.
It does.
But what it means is that normally I can always stay here and I can always sip from my coffee, which I still see there is some here. And I can put this object back and I can take it up again. Those are motions which I just made in space from my hand to the table. And it took a little bit of time, but I can bring the cup back where it was before to the same space. I cannot bring the cup back to the same time. I cannot go back in time. And the coffee I just drank is forever disappeared out of the cup. We cannot wind back the movie. But within a black hole, it's the other way. You cannot stay at the same point. Because to stay at the same point, you would have to go faster than the speed of light, which you cannot. And if you could go at a space faster than light, the time would become space. So the role of time in a black hole, if you would have a clock at a particular point, it would be a space clock, not a time clock. It's a bad. It's complicated. Forget that I said that. I mean, if I really would have to explain it, it's getting more complicated. But the basic idea is that space and time are reversed in role.
It's interesting. And so time travel can never exist, according to you?
Well, it really, first of all, in science, never say never. Because even in my own lifetime, I have seen so many no-go theorems in particle physics, which besides astrophysics is one of the areas which I I trained for as a graduate student to get my PhD. In particle physics, I've seen so many no-go theorems where somebody proved that something couldn't work. You cannot construct a theory which is like this, or you cannot expect something to happen like this. And in almost all cases, the way that these pronunciations were made, these theorems were derived mathematically, was to make a number of assumptions. And for example, as we said, if you assume that the universe has been created, then you automatically assume that there is a creator. And if you ask, who was the creator? Well, it depends. Was there really a creator? You have to ask one step earlier. Maybe, maybe not. But let's start with that question. So if somebody says, physics or science in general can never do this, or this type of theory, like faster than the speed of light, is always impossible. If you say that, then automatically you have all the tacit assumptions, all the things which we assume cannot happen. They all are being in there. And if one of them is wrong, then the result is wrong. So if a scientist say that something is measured and explained and within a certain accuracy is really determined, then you can believe that. But whenever scientists say, "Oh, this doesn't work," no go in technical terms, as it is sort of called as a joke, it's probably not right, but we don't know why it is not right. Sorry, that was a long answer.
No,
but this is
we needed that answer. It's really helpful. Let's talk a little bit about Elon Musk and SpaceX, shall we?
Okay.
How about you go first and just tell me your thoughts about just generally about what Elon is doing, SpaceX, what's happening, just to give your update.
Well, on the technical level, I'm happy to talk. On the political level, I will just...
Let's talk scientific then.
How do you say that in America? I pledge the fifth?
Yes.
See, I'm an immigrant, so...
No, let's talk the technical part of Elon Musk and SpaceX.
Okay. The technical part, I'm really so glad that when he started, 25 years ago, that he found a way to make space flight commercial. Because you need subsidies and you need the government to do something for the first time. For many reasons, the amount of money it costs and the amount of effort, and also as long as it's not commercially viable, industry will not do it. So the fact that that governments in the United States and elsewhere often have given subsidies or have built things themselves as a prototype is definitely what governments should do. But by the time things work well and are becoming commercially viable, I think it's a good idea that the government steps back and lets industry compete with different companies compete with each other, and let the government give contracts insofar as they still want to do pure research for which rockets and spaceships are possible. So I hope that at some point there will be at least 2 or 3 companies, and hopefully from different countries, which can compete with each other. At the moment, it has been almost one company show with Elon Musk's company. But as far as... okay, there are 2 steps here and 2 sides. Elon Musk's rockets will still be the place to go to commercially for quite a while.
Okay.
But the landers, when they go to the moon and later to Mars, there are already a bunch of commercial companies, at least half a dozen I know of, which make independent landers on the moon. So that is very positive thing that the commercial aspect. Airplanes have been commercial for a long time, but going to the moon is now really becoming commercial as well.
Right.
But you probably want to hear more about Mars. Yeah?
I do. Yes, I want to know about Mars. I want to know about this whole idea of humans literally building another, area to live in called Mars and essentially leaving Earth and going to Mars. Like the next generation, are we not going to be on Earth anymore? Are we going to be on Mars? What's going to happen?
Well, my best guess, and there are so many unknowns, my best guess is that bringing people to Mars and keeping them alive for a few months or a few years and then bringing them back, that will happen if there is the money for it and the interest. That is just almost literally the next step beyond going to the moon, which was done while I was in high school. It's just amazing it took so long. So that will happen. But it's an enormously big step to go from there to having a space colony. Mars is so far away from a life-friendly planet. I mean, I wouldn't even know where to get started in describing that.
Let's see where we can get here. According to you, where do you think we are in this mission? Like, you would be knowing more about the updates and what Elon and other companies are doing in terms of going to Mars. Like, what are the latest updates and like how far are we realistically in this search?
Oh, I think they, especially Elon Musk, but then at some point before too long, other companies as well, I'm sure. I think if Elon Musk would get the money to do so, I think I could see the first humans going to Mars maybe in 10 years or something like that. I mean, it's a matter of money more than a matter of technology, because it's basically a scaled up version of going to the moon. But on the moon, people had to walk around in spacesuits, and it was absolutely, I mean, a barren desert is full of life still with microbes on Earth, and the moon is completely sterilized and dead, and probably Mars is as well. And the atmosphere is so different from what we have here. You would have to walk around like you have to walk around on the moon in a spacesuit. And you have to live in a habitat in some sort of building which is completely isolated from the surrounding, like on the moon. And if we ever in some way go beyond that, that will be so far away. I mean, not a decade, not a few decades, much, much more than that, would be my guess.
Have people already started buying land there, or is that all a rumor?
I wouldn't know about that, but that seems a little bit premature. But they're also thinking about taking ownership on the moon. That is very serious.
Yes, I've heard of that.
Yeah.
Yes. Wow. Okay, let me ask you this. It's a very direct question. Will the world end? We can go a lot of different directions to this, but I guess from a scientific and in the context of astrophysics, if the world will end, what does that mean exactly? Like, will it just collapse? Is there a certain fate to the universe? Give me your take on that, Piet.
Well, as usual, with the type of questions type of very important questions you ask, my answer would be we have no idea.
That's the closest bet we have.
That is the closest answer, yeah. But we have some ideas. So in a sense, we have no firm idea, but we have many speculations. insofar as they are ideas. The best guess we'll have about the universe is that it will continue to expand. There is not enough matter and energy to stop the current expansion. That will continue. If you would have more a higher density of matter and energy, then the higher gravity could stop the expansion and let it collapse again. So our best guess is that it will continue to expand, and then in a way there would be no end to the universe, were it not for the fact that the stars will burn up. So at some point the universe will grow dark, and the matter will be all converted into burned out stars, and whether there is any type of life which could be formed out of burned out stars or planets or whatever, and little pockets here and there, is a whole other question. But this is speculation on top of speculation. So the good news is that it won't happen in the next few billion years. So if you're in a hurry, then I would say don't worry.
Mm. Just yesterday, we hosted a neuroscientist on our podcast, and he said something along the lines of that consciousness is essentially the only refuge to human exceptionalism. Consciousness in the aspect of, humans being self-aware, right? So my question is the universe self-aware? Like, if we have to categorize the universe as essentially a being, is it self-aware? Is it conscious in that sense, according to you?
To even begin that question, I have to take one fork in the road of two forks I can take.
Sure.
If I take the fork in the road of the current culture, our Western modern culture, in which we assume that matter is the basis of the universe. If we talk about the universe, we talk about the material universe, the stars, the galaxies, and there's at least one planet where there are life forms and human beings. And the human beings we also place in the universe as material beings on a material planet. And then if we ask about the mind and about consciousness, as you just did, we assume that consciousness is something connected with the brain and the immune system and everything else and our near environment. But if you have the whole universe in our culture, we think that a single human being is a very, very tiny piece of matter in some corner of the universe. And the human mind is connected with the human body in some way or other, which we may at some point be able to trace back to the way that the brain operates and the whole body operates. We are still very far from that. That is our modern religion in a way. We accept that. And most scientists I know are completely convinced that is by far the best model, if not the only way of thinking about the body-mind question or the body-mind problem. That we started with the material universe as a kind of a dogma, which you don't question. And if you question it, that is not science, or how can you think that way? So, been there, done that. I can I can tell stories about that too. But to start to end about this particular fork in the road, if you assume that I would say as a working hypothesis, since dogmas have no place in science, ideally. So as a working hypothesis that the mind is an emergent property from the brain. If a brain becomes complicated enough, you get consciousness. If it becomes even more complicated, you can self-reflect and you have consciousness of a type of a human being. And then the rest, the large picture is all material. And even the local picture is material as a brain. There is one fork in the road. And if I answer your question in this fork on the road, then I can give the same type of questions many other scientists will give, as you just mentioned. And that is not so interesting because my preferred fork in the road is a completely different one.
Okay.
It couldn't be more different. And almost, well, okay, let me just say it briefly and then I let you ask questions rather than me just going on.
Okay.
Very briefly, the other fork in the road is to say that as long as we don't know what the relation is between a brain or a body and a mind, as long as we don't know, let us start with the phenomena. Let us start what we can observe about how matter works, which we have done for 400 years, and we have gone to the moon with science, which engineering couldn't have done. You couldn't build a bridge very far. We have brought the power of the sun to Earth, which may have been a very bad move, but if you can use it in a peaceful way, that might be a very good move. But we have connected our planet with the moon and the sun through science, which we could not have done through engineering. Now, we have never used a few hundred years of the best minds to study matter. We have never done a similar amount of dedication to understand the depths of the mind. And other cultures have tried to do that, have done that in different other cultures, and to see what we could possibly do with the science of mind. I would prefer not to assume that there is some sort of magical connection between matter and somehow a particular configuration of matter somehow produces a mind. I would say no. Let us study mind using the mind as a laboratory for studying the mind with the same carefulness and the same methodology, basic methodology, as what we have used for matter. So, and within that branch, that fork in the road, there is nothing I can say because it hasn't even started. So I would say all guesses are open there.
Interesting. Do you have any thoughts on déjà vu in its relationship with astrophysics? Or I don't know if that's something you've ever been asked.
Well, like many people, I've had some moments which I think you can classify under déjà vu. Also, what I am most interested in is to, especially now that I started a program called FEST, Fully Engaged Science and Technology, to take the method of science in the study of matter and to see what can be carried over as a first principles foundation to the science of mind. To start that up, I would not study something like déjà vu because I would like to follow the example of Galileo and other people in the 17th century of studying very, very simple things like the motion of falling balls or the motion of planets, which are complicated, but not as complicated as the motion of leaves falling from a tree or turbulent water or whatever. That is not how you start. So the study of the mind that I see as a new approach to make it really scientific and universal would start with much simpler things than déjà vu.
Thank you so much. Thank you. It was an honor having you.
Thank you.